This short presentation introduces novel findings from our multi-year case study of normal tension glaucoma progression. The study included unprecedented, weekly, precise, high-res OCT tracking of both fluid accumulation and retinal nerve fiber layer RNFL loss, yielding a surprisingly simple relationship between RNFL loss and strenuous activity time and intensity, allowing estimation of RNFL loss in response to activity. We then hypothesized that this relationship was driven by bleeding from small optic nerve head vessels, microhemorrhages, which we subsequently confirmed by direct observation. These findings suggest that, in some cases where IOP is well controlled, strenuous activity may become the key modifiable risk factor for progression. Next, we'll take a closer look at the research by summarizing our major presentations. So what did we find? Results are reported in two presentations. The first, when activity trumps IOP, begins with the story of how, after the subject's retirement, major yard and home projects led to significant retinoschisis in both eyes, with both inner and outer retina fluid accumulation driven by optic nerve head vessel leakage revealed by fluorescein angiography, with subsequent glaucoma progression as measured by RNFL loss, suggesting the simple hypothesis that strenuous activity produces vessel leakage, likely from optic nerve head microhemorrhages, potentially resulting in fluid accumulation, retinoschisis, and subsequent RNFL loss. We then proposed studying this subject much more closely with weekly or twice weekly high-res optic nerve head and triplicate RNFL OCT scans during a multi-year period without major yard or home projects to determine the nature of any underlying relationship between strenuous activity and progression and how that might be better managed. 3 years of close tracking, thousands of OCT scans, with daily mean IOP near 15, revealed discontinuous RNFL loss triggered by multi-day clusters of strenuous activity, with RNFL loss taking about 8 weeks to complete after each cluster. These losses occurred despite the period being free of extreme activities and major retinoschisis or classic optic disc hemorrhages. RNFL loss as the sum of bilateral sector micrometer losses was found to be a remarkably simple cubic function of the total hourly time and intensity of each cluster strenuous activity. For example, tripling cluster strenuous activity time increased risk 3 cubed, or about 27 times. In general, splitting strenuous activity into smaller times greatly reduced RNFL loss, whereas combining strenuous activity into larger clusters greatly increased RNFL loss. A model based on this simple relationship closely tracked RNFL loss during the 2021 to 23 study period. These surprising and unprecedented results relating strenuous activity directly and quantitatively to subsequent RNFL loss also suggested there may be a correspondingly simple underlying, not yet exposed relationship between activity, vessel leakage, and RNFL loss for this subject. Our second presentation, Vessel Leakage Exposed, describes additional close tracking of the consequences of a Valsalva-based strenuous activity cluster, which triggered a microhemorrhage, leakage from which reached RNFL with subsequent RNFL loss. The exact sequence previously hypothesized as the link between strenuous activity and glaucoma progression in this subject. Fluid accumulation and removal was closely tracked to reveal microhemorrhage leak rate over time. Combining such results from the 5 years of study produced a model relating leak size, duration, flow, and total volume, leading to a simple quantitative relationship between strenuous activity, vessel leakage from microhemorrhages, microleaks, and subsequent RNFL loss, and with many important implications for treatment, such as the effect of aging on microhemorrhage risk via hormones and reduced wound healing, the effect of blood pressure and venous pressure spikes accompanying strenuous activity on microhemorrhage risk despite IOP lowering, and the possibility that a history of microhemorrhage from poor activity management may make future leakage and progression more likely. This suggests a quite different approach to treatment for this type or stage of glaucoma, compared to simply lowering IOP below normal, often with little discussion of the potential risks of strenuous activity. For this subject, IOP near 15 was probably not a significant risk factor, whereas strenuous activity was a major modifiable risk factor for glaucoma progression, with progression being discontinuous, largely driven by multi-day clusters of strenuous activity, including activities involving common home and yard work. RNFL loss took about 8 weeks after each cluster to complete, with loss having a surprisingly simple relation to activity time and intensity. Finally, optic nerve head microhemorrhages were found to be the likely link between activity and progression. Since this subject is similar in many respects to other normal tension glaucoma patients, and with a family history of glaucoma, this suggests that these novel findings may have some relevance to many other glaucoma patients. Hence our interest in making these results readily available to the glaucoma community. Visit our report site at watiop.net for additional study info and implications, as well as full presentations as videos, slides, or printable PDFs.